On a quiet night in July 2025, a telescope in Chile noticed something unusual, a tiny point of light drifting slowly across the darkness. At first it looked ordinary, just another faint object among millions, but within hours, astronomers realized this was different. Its path did not belong to our solar system. It was coming from somewhere far beyond. They named it 3I Atlas. The I stood for interstellar, meaning it came from another star system. And with that single discovery, humanity had found its third visitor from the deep unknown. Before this, we had seen only two. In 2017 came Oumuamua, a mysterious cigar-shaped body that slipped past Earth at incredible speed. 2 years later, in 2019, came 2I Borisov, a comet that looked more familiar, shedding gas and dust like those born in our own system. Now, 3I Atlas became the third, a traveler from the stars, moving through our neighborhood for the briefest moment in time. Atlas stands for Asteroid Terrestrial Impact Last Alert System, a network of telescopes designed to spot asteroids that could threaten Earth. But on July 1st, it caught something no one expected. An object moving so fast, its orbit was not an ellipse, but a hyperbola, a path that would carry it in, round the sun, and then back out to the stars forever. This meant it was not bound to the sun's gravity. It did not belong here. As data poured in from around the world, scientists confirmed it. This was an interstellar comet, a fragment from another solar system, passing through ours by pure chance. Its speed was astonishing, about 60 kilometers per second, more than 200,000 kilometers per hour. At that pace, it could circle the entire Earth in just 7 minutes. The object entered the solar system from the direction of the constellation Sculptor. It crossed the path of Mars and headed toward the Sun, reaching its closest approach, about 1.4 astronomical units away, at the end of October. Then it would leave again, disappearing into the dark. For astronomers, every moment mattered. Telescopes from Hawaii, Spain, Japan, and Chile turned to watch. Even the Hubble Space Telescope locked on. Because once an interstellar visitor passes the Sun, it fades quickly. If you miss it, you never see it again. Through Hubble's lenses, 3I Atlas looked like a small bright dot with a soft halo of gas, a coma. Round-based telescopes measured its brightness and dust. Its core, or nucleus, is probably between a few hundred meters and a few kilometers wide, tiny by planetary standards, but big enough to carry the chemistry of another world. When sunlight struck it, the surface released carbon-rich gases. Spectrographs showed signatures of molecules like CN and C2, the same compounds that make some comets glow green. But the ratio of materials was different from the comets we know. It seemed drier, with less water vapor and more carbon chains. That meant it likely formed far from its parent star, in a colder, darker region than anything near our Sun. Imagine it, a frozen rock born around another star billions of years ago, thrown out of its home system during the violent birth of planets, drifting through interstellar space for eons, until one day, by pure coincidence, it passed close enough for us to notice. Every interstellar object is a messenger, a small piece of another solar system, carrying clues about how planets form elsewhere. Oumuamua showed us that alien debris can look nothing like what we expect. Borisov showed us that some are familiar, icy comets, not so different from our own. And now, three Irles bridges, those two lessons. It behaves like a comet, but carries chemistry that is distantly foreign. As it approached the sun, its activity increased, releasing more gas and dust, but even near peak heating, it stayed intact, unlike some comets that crumble. Its brightness curve rose and fell smoothly, suggesting a stable rotation. For scientists, that stability was gold. It allowed detailed observations across multiple wavelengths: optical, infrared, and ultraviolet. NASA, the European Space Agency, and observatories around the globe launched a coordinated campaign to study it. Dozens of research teams, hundreds of hours of telescope time, and millions of lines of data, all focused on a single tiny visitor that would never return. By late October 3-Period, its closest point to the sun, it brightened slightly, then began to fade as it moved away. No mystery signals, no sudden disappearances. Just physics in motion: sunlight, ice, dust, and time. A traveler competing its curve around our star before vanishing into the infinite dark. So what have we learned from this brief encounter? First, that interstellar objects may be far more common than we once thought. Most are simply too small or faint for our instruments to detect. Second, that the building blocks of distant planetary systems are much like ours: carbon, oxygen, nitrogen, ice, and dust. And third, that when the universe sends a stranger through our skies, we have the technology and cooperation to recognize it, study it, and learn, because behind every data set there is wonder. Behind every telescope there is a human looking up, asking, where did this come from, and how far has it traveled? Think about it. 3. Atlas may have been orbiting another star billions of years before our sun even existed. Long before Earth formed, before the first cell of life appeared, this small fragment was already adrift between stars, and now, for a few weeks, its path crossed ours. It is easy to think of the universe as silent and empty, but every now and then something passes by to remind us. The stars are connected. Material from one system can reach another. In a way, the galaxy shares its stories through these wanderers. 3-Atlas will soon be gone, fading beyond the reach of our telescopes. But the data it left behind will keep scientists busy for decades, measuring composition, modeling origin, and refining how we search for future visitors. Each discovery builds on the last. Oumuamua, Borisov, Atlas. 3 messengers, 3 lessons. 1. That cosmic debris can take strange shapes. 2. That familiar chemistry exists everywhere. And 3. That our solar system is not alone in its story of creation. These are not myths. They are real pieces of other worlds, drifting between the stars. And once in a while we are lucky enough to catch one. So when you look up at the night sky, remember this: every point of light could be a sun. Every sun could have planets. And from those planets, fragments can be thrown into eternity, wandering for ages, until one happens to pass by a small blue world, orbiting an average star, where curious minds weep to notice. 3. Atlas reminds us that exploration is not always about rockets or astronauts. Sometimes it is about watching carefully. Sometimes it is about patience. And sometimes it is about realizing that the universe still has stories to tell if we have the courage to listen. Because science is not the search for certainty, it is the courage to wonder. 3. Atlas came from the stars. It passed by quietly, and as it leaves, it takes nothing from us except our breath. This is not the story of a mystery. It is the story of curiosity itself, of how far a single rock can travel, of how small we are, and yet how much we can understand. So let the numbers fade, and hold on to the feeling. Somewhere out there, drifting between suns, is a silent green-tinged traveler that once passed through our sky. We called it 3E8, and though it is gone, its lesson remains. We are part of something vast, something ancient, something still unfolding. And maybe somewhere in another sky, another civilization is watching their own telescope screens, seeing a faint point of light that does not belong, and whispering the same words we once did. What is that? Where did it come from? And what can it teach us?